1 is just introducing you to the concept of prime numbers. Prime numbers are sort of the building blocks of all math and a lot of applications in the world, cryptography and computer science and things like that. Their basis is in the concept of prime numbers. Prime numbers is important for things like factoring. You can get things to its simplest, when you some things in its simplest forms in terms of math, it's factored down to prime numbers. A prime number is something that is only divisible by 1 and itself. However, 1 is not a prime number. So when you're looking at numbers, you need to think about whether or not it can be divided by anything. So like 5 can't be divided by anything but 5 and 1. 10 can be divided by 2, so it is not a prime number. So something that's not a prime number is called a composite number. So every number on the planet is either a prime number or a composite number. When you're trying to figure out whether something is prime, you start dividing other smaller primes into it. After a while, you'll get to know what they are, like 2, 3, 5, 7, and then don't forget to check with larger numbers like 13 and 17, because some of those higher numbers in the hundreds will trick you with a 13 or being divisible by something like 17 where it's not visibly obvious. You can immediately rule out anything that ends in an even number other than 2, because that means it's divisible by 2. You can immediately rule out anything that ends in a 5, because that means it's divisible by 5. Things like that. You'll learn tricks like that, and you'll see that there's actually not too many prime numbers out there that you're going to be dealing with. But to find the prime numbers, you just try and plug it away and see if there's any prime number smaller than that number that can divide into it evenly. If not, then that's a prime number. If something can, then it's a composite.